why it's impossible to find intelligent life out there. You see, for more than 60 years now, we've been deliberately and patiently trying to discover whether intelligent life exists beyond Earth. We've constructed vast radio telescopes and aimed them at the sky. We've launched probes far from our planet, pushing them into the darkness between the stars. We've catalogued and examined thousands of exoplanets, worlds orbiting distant suns. We've searched for signals, for technosignatures, for any clear sign that intelligence has arisen elsewhere. And what have we uncovered? Nothing at all. Complete silence. Not a single confirmed detection, not one verified signal, not even the faintest suggestion that another technological civilization exists anywhere within the observable universe. And I want to share something that many scientists hesitate to say openly, something that runs counter to the hopeful stories often told in documentaries and popular science writing. The issue isn't simply that we haven't found intelligent life yet. The deeper possibility is that finding it may be impossible. Not necessarily because the universe is empty, although that remains a possibility, but because of profound limits set by physics, by biology, by the very nature of intelligence, and by the immense statistical scales of cosmic time. The sobering conclusion emerging from decades of careful research is that humanity could be the last intelligent civilization in the observable universe, perhaps even the final one that will ever exist. And the likelihood that we will ever encounter another technological species may be effectively zero. Now, that is an extraordinary claim, and it deserves to be supported with care because it clashes with intuitions and optimistic assumptions that have shaped our thinking about extraterrestrial intelligence since the 1960 seconds. So let me guide you through the reasoning step by step. Beginning with the most well-known formula in the search for extraterrestrial intelligence, the Drake equation, and explaining why each term in that equation is almost certainly far smaller than enthusiasts tend to assume. Why the filters and barriers standing in the way of intelligent life are far harsher than we usually acknowledge, and why, even if intelligent civilizations do arise elsewhere, the odds of ever detecting them or exchanging messages with them are so small that they fade almost entirely into insignificance. The Drake equation, introduced by Frank Drake in 1961, was designed to estimate how many detectable civilizations might exist in our galaxy by multiplying a series of factors together: the rate at which stars form, the fraction of those stars that host planets, the number of planets per star that lie within the habitable zone, the proportion of those planets where life actually arises, the fraction where life evolves into intelligent forms, the fraction where that intelligence develops technology capable of interstellar communication, and the length of time such civilizations remain detectable. When Drake first formulated this equation, the optimistic thinking of that era produced estimates of thousands, or even millions, of communicating civilizations in the Milky Way. This created enormous enthusiasm about the prospect of detecting alien signals and making contact. But as our knowledge of each component has improved, as we've discovered exoplanets, investigated the origins of life, and gained a deeper understanding of evolutionary biology and cosmic history, those estimates have collapsed dramatically. Every single factor turns out to impose far stricter limits than early optimists imagined. And when all these small probabilities are multiplied together, the result approaches one or even less, implying that we may be alone in the galaxy, or at least so uncommon that detection becomes practically impossible. Let me examine these terms individually and show why each one is more challenging than it first appears. Begin with stars and planetary systems. These were once thought to be the most encouraging parts of the equation, and observations have indeed confirmed that planets are widespread. The Kepler mission revealed thousands of exoplanets and demonstrated that almost every star hosts planets, with many stars possessing planets located in the habitable zone, where liquid water could exist on a planet's surface. At first glance, this seems very hopeful. It suggests that there are billions of potentially habitable worlds in our galaxy alone. It feels natural to assume that at least some of these worlds must have given rise to life and intelligence. But this is where the first major difficulty emerges. The habitable zone is far less hospitable than its name implies. Being located at the right distance from a star, where temperatures allow liquid water, is a necessary condition, but it is nowhere near sufficient for life to develop. A planet also requires the correct atmosphere, appropriate atmospheric pressure, the right mix and balance of greenhouse gases, and effective shielding from harmful radiation through magnetic fields and ozone layers. It needs plate tectonics to recycle carbon and sustain a stable climate over geological timescales, a large moon to stabilize its axial tilt and prevent extreme or chaotic climate swings, suitable orbital eccentricity and inclination, protection from catastrophic asteroid impacts provided by gas giant planets in distant orbits, and many dozens of additional conditions that must align precisely. Earth is not merely positioned within the habitable zone. It is the outcome of an extraordinarily specific chain of events and circumstances that may be exceptionally rare. The moon itself formed through a colossal impact at just the right size and angle, creating a large satellite without destroying the planet. Jupiter and Saturn occupy positions that divert most comets and asteroids away from the inner solar system, while still allowing some impacts that delivered water and organic material. Earth's magnetic field arises from a liquid iron core kept active by radioactive decay and tidal forces, and this field has endured for billions of years, shielding the atmosphere from the solar wind. The atmosphere achieved its present composition through volcanic outgassing, photosynthesis, and chemical weathering, a fragile balance that could easily have failed. Water blankets much of the surface, but not all of it, leaving exposed land where complex ecosystems and eventually technological civilization could emerge. And the list continues. When you attempt to calculate the likelihood that all of these factors coincide on a single world, the probability shrinks extremely quickly. Peter Ward and Donald Brownlee argued in their book Rare Earth that while simple microbial life might be widespread, complex multicellular organisms, and especially intelligent life, depend on such narrowly defined conditions that Earth-like planets may be extraordinarily uncommon, possibly unique within the galaxy or even the observable universe. Although not all scientists accept the most extreme interpretations of the rare Earth hypothesis, its central argument remains compelling. Habitability involves far more stringent requirements than simply occupying the correct temperature range around a star. And the reality is that most planets located within a so-called habitable zone are probably not genuinely suitable for complex life at all. As a result, the true number of planets that can actually support advanced biology is far smaller than the simple count of habitable zone worlds would imply. It could be smaller by many orders of magnitude, perhaps reduced by factors of millions or even billions, once all the necessary conditions are taken into account. This immediately slashes the estimates produced by the Drake equation right from the outset. But let's assume, for the sake of argument, that there are still millions of truly habitable planets in our galaxy, worlds that satisfy every requirement for complex life. Surely, then, life must arise on at least some of them? This is where we encounter the second major limitation, the origin of life itself. We have only a single confirmed example of life beginning, here on Earth, and we still have no clear understanding of how it happened. We don't know which precise chemical pathways were involved, what exact environmental conditions were required, how likely the process is, or whether life emerges inevitably when conditions are right, or whether it is extraordinarily unlikely. Life appeared on Earth remarkably early, within the first few 100 million years after the planet cooled enough to sustain liquid water, which might suggest that life emerges easily and quickly whenever circumstances allow. Yet we cannot dismiss the possibility that we were astonishingly fortunate, that the origin of life is so improbable that it occurs only once among billions or even trillions of planets, and that Earth simply happened to be that rare success. The chemistry underlying the origin of life is immensely complex. It requires the spontaneous formation of self-replicating molecules, most likely RNA or something closely related, from simple organic compounds through random chemical reactions. But RNA itself is highly intricate. It demands very specific nucleotide sequences capable of folding into structures with catalytic functions, and the chance of randomly assembling even a short, functional RNA molecule is astronomically low. Some form of chemical evolution must have occurred, a process that concentrates molecules, organizes them, and selects for sequences that are useful. Yet we do not know what that process was, or even whether it is likely to happen naturally. Laboratory experiments have demonstrated that certain building blocks of life, such as amino acids and nucleotides, can form under prebiotic conditions, but the step from basic components to fully self-replicating systems is vast, and one we have never managed to reproduce in the lab despite decades of effort. It is therefore entirely plausible that the origin of life is a 1 in a trillion event, that most habitable planets remain lifeless forever, and that Earth is the only place in the galaxy, or even in the observable universe, where life ever began. This idea is known as the Great Filter, a barrier so difficult to overcome that it could explain the absence of any evidence for extraterrestrial civilizations. One possibility is that this filter lies in our past, that the emergence of life itself is the most difficult step, and that once life exists, subsequent developments are comparatively easy. If that is the case, then even with billions of habitable planets, the number that actually host life might be 1, or a handful, or perhaps a few dozen, while the number that develop intelligent life could effectively be 0 apart from us. We simply do not have enough information to rule this out. We cannot derive the probability of life's origin from first principles, and observing a single example tells us almost nothing about the true distribution of probabilities. But let's take a more optimistic view and assume that life is fairly common, that it arises on millions of planets across the galaxy. Even then, we still face the challenge of progressing from simple microbial life to complex multicellular organisms, and then from complex life to intelligence, with each transition potentially being extremely unlikely. On Earth, life remained purely microbial for more than 3 billion years, consisting of single-celled organisms from about 3.8 billion years ago until roughly 600 million years ago. Even after that, the shift to complex multicellular life occurred in a sudden and dramatic burst known as the Cambrian explosion, which may have depended on very specific and unusual conditions. The emergence of eukaryotic cells, cells with nuclei and complex internal structures, was likely a singular event in Earth's history, a one-time merger between different types of bacteria that produced an entirely new kind of organism with vastly greater potential for complexity. This endosymbiotic event, in which one bacterium engulfed another and they formed a permanent cooperative relationship rather than one consuming the other, may be so improbable that it happens only once among billions of life-bearing planets. And without eukaryotic cells, the development of complex multicellular organisms is simply not possible. You are effectively confined to bacteria and archaea indefinitely. Nick Lane has argued that the energetic limits of prokaryotic cells, bacteria that lack mitochondria, make it essentially impossible for them to evolve the level of complexity required for multicellular life. His point is that without the dense, efficient energy supply provided by mitochondria, cells simply cannot sustain the elaborate protein machinery, internal structures, and signaling systems that complex cells depend on. If this argument is correct, then the leap from prokaryotes to eukaryotes represents another great filter, another major hurdle that the vast majority of life-bearing planets never overcome. As a result, the number of worlds hosting complex multicellular organisms is enormously smaller than the number of worlds inhabited only by simple microbial life. And even among planets where complex multicellular organisms do emerge, those cases may still be uncommon. Intelligence is not guaranteed. It is not the destination toward which evolution is aiming. It is merely one survival strategy among many, and for most of Earth's history, it offered little or no advantage. By almost every measurable standard, bacteria have been far more successful than humans. They have existed for billions of years. They inhabit virtually every environment on Earth. Their total biomass outweighs that of all plants and animals combined. And they will almost certainly persist for billions of years after humans are gone. Intelligence comes at a high energetic cost. Brains require vast amounts of energy relative to body mass. For most organisms, and in most environments, that cost is not worth paying. Simplicity and resilience are often better strategies than complexity and fragility. Rapid reproduction in large numbers is often more effective than producing a small number of offspring that require heavy investment and large, energy-hungry brains. So, intelligence may be a statistical accident, a rare evolutionary outcome that occurred on Earth because of very specific selection pressures within our lineage. The social complexity of primates, the demands of tool use and communication, the benefits of cooperation, culture, and cumulative learning. But those same pressures may not arise elsewhere, even on planets that host complex life. Earth has supported complex multicellular organisms for 600 million years, yet only a single lineage developed technological intelligence. Out of millions, perhaps billions, of species that have existed, only one learned to control fire, build tools, develop agriculture, and eventually construct radio telescopes. That represents a success rate that is effectively zero, 1 in billions, and there is no compelling reason to assume other planets would fare any better. Most complex life never becomes intelligent. Intelligence is not the default result of evolution. It is an exceptionally rare accident that may depend on very particular conditions and selection pressures that simply do not exist elsewhere. When you multiply all these probabilities together, the fraction of habitable planets, multiplied by the fraction where life begins, multiplied by the fraction where life becomes complex, multiplied by the fraction where complex life develops intelligence, you arrive at a value that could easily be less than 1 for the entire galaxy. In that case, we may be the only intelligent species in the Milky Way. And even if that value is greater than 1, even if there are a few or perhaps a dozen intelligent species scattered across the galaxy, they are distributed among hundreds of billions of stars, separated by thousands or tens of thousands of light years. Under those conditions, the probability of detecting one another becomes vanishingly small, for reasons I will explain shortly. Before that, however, there is another constraint that makes the problem even more severe, and that is the issue of time. Intelligent civilizations may exist at different moments rather than at the same time, and the period during which they are detectable may be extremely brief. The galaxy is more than 13 billion years old. The Sun and Earth are only 4.6 billion years old, which means the galaxy existed for over 8 billion years before our solar system formed. Throughout that immense span of time, stars have been forming, planets have been created, and some fraction of those planets may have been habitable, with some fraction developing life and intelligence. Intelligent civilizations could have arisen 5 billion years ago, or 8 billion years ago, or at almost any point in the galaxy's long history. Those civilizations might have endured for a few thousand years, or a few million years, or they might have vanished, transformed, or transcended in ways we cannot comprehend. The crucial point is that even if intelligent life is not extraordinarily rare, even if thousands or millions of intelligent species have existed over the galaxy's lifetime, they may never coincide in time. They may appear and disappear before others ever arise, like ships passing in the cosmic night, never aware of one another's existence. And this scenario is entirely plausible, because the window during which a civilization can be detected may be extremely short. We've only possessed the ability to communicate via radio for roughly 100 years. For just about a century, we've been unintentionally sending signals into space through radio broadcasts, television transmissions, and radar. But those signals are steadily diminishing as we transition toward fiber optics, digital networks, and tightly focused communications that leak far less energy into space. That means the period during which a civilization is loudly visible through radio emissions may last only a few centuries, before it either collapses or advances to technologies that no longer produce easily detectable signatures. Within that narrow window of a few centuries, a civilization is only detectable out to about 100 light years, which is simply the distance those signals have had time to travel. That range represents an extremely small portion of the Milky Way, perhaps only 1/10,000th of the galaxy's total volume. At any given moment, then, A civilization is visible only within a tiny bubble of space surrounding it, and unless another technological society happens to lie inside that bubble at the same time, and is also actively observing in the right direction with sufficiently sensitive instruments, it will never notice those signals at all. The same limitation applies in reverse. If another civilization exists 1,000 light-years away, we could only detect it if it happened to be transmitting during the brief period when its signals are just now reaching us. For them, that transmission might have occurred 1,000 years ago, and they may have gone silent or disappeared entirely long before their signals ever arrived here. So, even if the galaxy has hosted many intelligent civilizations throughout its history, the chance that two of them exist simultaneously and close enough to detect one another is extremely small. It's not enough to align in space. You must also align in time. And that temporal overlap is vanishingly short when compared to cosmic timescales, meaning that most civilizations never coincide. This alone dramatically reduces the effective number of detectable civilizations, potentially by many orders of magnitude. When this factor is incorporated into Drake equation estimates, the resulting values begin to approach zero. Now, let me explain why. Even if all of this reasoning is wrong, even if intelligent life is far more widespread than I've been suggesting, detection would still be effectively impossible for several additional reasons tied to the physics of interstellar communication and the nature of intelligence itself. To begin with, there is the staggering energy cost required to transmit signals that can be detected across interstellar distances. Radio waves spread out as they propagate, and their strength falls off with the square of the distance. A signal that is easy to detect at 1 light-year becomes 1,000 times weaker at 10 light-years, and 1,000,000 times weaker at 1,000 light-years. Sending a signal powerful enough to be noticed across thousands of light-years demands an immense amount of transmitting power, on the scale of gigawatts or more, and if you don't know where potential receivers might be, you would have to broadcast continuously in all directions, multiplying the energy requirement by thousands or even millions. This represents a colossal commitment of resources. It would mean allocating a significant fraction of a civilization's total energy output to transmitting messages into space, merely on the chance that someone might receive them decades, centuries, or even millennia later. There is no compelling reason to expect a civilization to make such an investment. The return is extraordinarily poor. Vast resources are expended over centuries, while the probability of receiving a reply remains extremely small due to the scarcity of intelligent life and the immense delays imposed by distance. If a signal reaches another civilization 1,000 light-years away and they choose to respond, the total round-trip time before you receive that reply would be 2,000 years. By then, your civilization may have transformed beyond recognition or ceased to exist altogether. As a result, deliberate interstellar broadcasting is likely to be exceedingly rare. Most civilizations probably avoid it because the cost far outweighs any plausible benefit. The only signals that might be detectable, then, are accidental leaks from communications never intended to travel between stars. And those signals are faint, short-lived, and extraordinarily difficult to separate from background noise across interstellar distances. There is also the sheer scale of the search itself. Even if civilizations are transmitting, we must be looking in exactly the right direction, at exactly the right moment, and at the correct frequency to detect them. The sky is vast, containing billions of stars that could potentially host life, and the radio spectrum spans an enormous range of frequencies. We have no way of knowing which frequencies another intelligence might choose to use. They could be transmitting in bands we have barely examined, or employing modulation methods we don't recognize, or using technologies beyond radio altogether that lie entirely outside our detection capabilities. In this sense, SETI, the search for extraterrestrial intelligence, is like hunting for a needle in a haystack the size of the galaxy. And the needle may not even exist. It could be made of something we cannot detect, or it might only appear briefly before vanishing again. So far, we have explored only a tiny fraction of the vast parameter space available to us. We have examined only a few thousand stars out of the hundreds of billions that exist in our galaxy. We have explored just a very narrow slice of the possible frequency spectrum, and we have done so for relatively short intervals, often assuming that any signal would be continuous or regularly repeated. But what if extraterrestrial transmissions are fleeting? What if they transmit for only a few minutes each year? Or what if they rely on spread spectrum methods that cause their signals to resemble background noise unless you already understand the encoding? Or perhaps they intentionally choose not to be detected, out of caution or due to cultural priorities. In all of those cases, our searches would fail to notice them. Even if such civilizations were relatively close to us, we could be surrounded by them and remain completely unaware simply because we are not searching in the right way. And this challenge only intensifies with time, because as our own technology progresses, we are becoming quieter. We leak far less radiation into space than we once did. We rely increasingly on efficient, tightly directed communications, fiber optics, and encryption that renders our signals indistinguishable from random noise. If other civilizations follow a similar technological path, then the period during which they are detectable becomes even shorter than previously imagined, perhaps only a few decades during the transition from early radio use to more advanced systems. The chance of observing a civilization during that brief window becomes vanishingly small. Third, there is the possibility that intelligence does not necessarily lead to technology, or that it leads to technology for such a short time that it remains undetectable. We often assume that intelligent life will naturally develop radio telescopes, space programs, and a desire to communicate. But that assumption is deeply human-centric. It reflects our own specific form of intelligence and our particular cultural values. Intelligence can manifest in many different ways, and there is no reason to believe that all intelligent species would become technological. They could be intelligent in forms that do not result in tool-making, science, or curiosity about the wider universe. Dolphins and whales, for example, are highly intelligent, with sophisticated communication systems and complex social structures. Yet they inhabit an environment where technology is effectively impossible. They cannot manipulate their surroundings in the necessary ways, cannot make fire or tools, and cannot develop science. If intelligent aquatic species are common on other planets, and they might be, given that oceans are stable environments that could support complex life more readily than land, then such species would never become detectable regardless of how intelligent they are. Alternatively, consider the possibility that intelligence does evolve into technology, but only briefly, because that technology leads to self-destruction. This is the most pessimistic reading of the Fermi paradox. In this view, the great filter lies ahead of us rather than behind us. Technological civilizations inevitably destroy themselves through nuclear conflict, environmental collapse, artificial intelligence, or catastrophic bioengineering, and the typical lifespan of a detectable civilization is only a few decades or centuries before extinction. If that is the case, then the galaxy may be filled with the remains of dead civilizations, with ruins, fossils, and enduring radio silence, species that briefly achieved technology and then vanished. The reason we do not detect anyone would be that no one survives long enough to be detected. This would neatly explain the silence. It would suggest that intelligence itself is common, but technology is self-limiting, a path that leads not to expansion, but to extinction. And it would imply that we are destined to follow the same route unless we can somehow avoid the traps that claimed all those who came before us. Now, I want to consider an even deeper reason why discovering intelligent life might be impossible, and this one relates to the nature of intelligence itself and the way it evolves over time. When we imagine detecting extraterrestrials, we are implicitly assuming that they will resemble us in some recognizable way. Technological civilizations that use radio waves or visible light, that build structures we can identify, and that possess motivations we can comprehend. But this assumption is almost certainly mistaken. Any civilization that is significantly more advanced than ours would be so different from us that we might not recognize it as intelligent at all. Such beings could be invisible to our searches, not because they are hiding, but because they have moved beyond the technological phase we know how to detect and entered a realm entirely outside our understanding. Consider our own history. 1,000 years ago, humanity had no electricity, no radio, and no computers. 500 years ago, we lacked telescopes and had no grasp of heliocentrism. 100 years ago, nuclear energy, space travel, and modern computing did not exist. Just 50 years ago, there was no internet, no genetic engineering, and no artificial intelligence. The rate of change is accelerating, and there is every reason to think that this acceleration will continue. Technologies that once seemed impossible only a few decades ago have now become part of everyday life, and if we project this trend forward by even a few centuries, let alone thousands, millions, or tens of millions of years, human civilization, or whatever descends from it, will be utterly unrecognizable. The tools will be unimaginably advanced, the powers they grant extraordinarily vast, and the very meaning of existence so radically altered that describing it as human civilization may no longer make sense. We may choose to upload consciousness into computational systems. We may fuse our minds with artificial intelligence. We may redesign our own biology so completely that no trace of our current form remains. We may spread into space in configurations that are no longer biological at all. We may uncover layers of physics beyond our present understanding and learn to use them in ways that are currently beyond imagination. And if this is the likely path over mere centuries or millennia, then consider a civilization that is 1,000,000 years older than ours, or 10 million, or even 100 million. To such beings, we would relate as we do to bacteria. Their technologies would seem indistinguishable from magic. Their intentions, values, and objectives would be impossible for us to comprehend. They might surround us completely and yet remain unseen, simply because we do not know what to search for or lack the senses to perceive the dimensions in which they operate. They could exist as pure energy or as patterns of information. They might directly manipulate space-time itself. They might have abandoned physical space entirely in favor of simulated realities. They may possess abilities that appear to violate the laws of physics as we understand them, not because those laws are broken, but because they grasp deeper principles that remain unknown to us. Civilizations of this kind would not be transmitting radio signals. They would not be constructing Dyson spheres or vast megastructures that our telescopes could identify. They would not be doing anything that fits our definition of technology, because they have moved so far beyond that stage that our entire conceptual framework for intelligence and technology has become obsolete. This idea is often referred to as the transcension hypothesis, which proposes that sufficiently advanced civilizations inevitably transcend. They move beyond physical space and conventional matter and energy, pursuing goals such as extreme computational efficiency, entropy minimization, or the exploration of abstract mathematical realms that require leaving the physical universe behind. If this transition happens rapidly, if the shift from radio communication to transcendence occurs within just a few thousand years, which is an instant on cosmic timescales, then the period during which a civilization is detectable becomes extraordinarily brief. In that case, almost all intelligent life in the universe would exist in post-transcendent states that we cannot observe and would not even recognize as life or intelligence. The galaxy could therefore be filled with advanced minds, billions of post-biological civilizations operating in substrates we cannot perceive, guided by principles we do not understand. And we would remain completely unaware of their existence, because our searches are designed to find civilizations like ourselves, trapped in a short-lived technological adolescence that lasts only millennia before transcendence occurs. This line of reasoning leads to a profoundly unsettling conclusion. We may be alone not because intelligence is rare, but because we are early. The universe is 13.8 billion years old. Yet the Sun is a third-generation star. Earlier generations contained fewer heavy elements and may not have been capable of forming planets with the complex chemistry required for life as we know it. The period when Earth-like planets became common may have begun only a few billion years ago, meaning that we could be among the first civilizations to emerge, early adopters of intelligence in cosmic history. Most intelligent life may lie in the future, arising billions of years from now on planets orbiting red dwarf stars that will burn for trillions of years, or on worlds that do not yet exist, because their parent stars are still forming within clouds of gas. If we are early, if we belong to the first few percent of all intelligent species that will ever exist, then the silence makes sense. There is no one else to see yet. The universe is young and largely empty, and we are the first, or among the first, to look into the night sky and ask where everyone is. But here is the troubling twist. If we are early, and most intelligence lies ahead of us in time, then we may also be vulnerable because of something known as the anthropic shadow. The anthropic shadow refers to the fact that we cannot observe existential catastrophes that would have prevented our existence. We can only find ourselves in histories where those disasters have not yet occurred, which means our observations are inherently biased toward underestimating existential risk. When applied to alien intelligence, the anthropic shadow suggests that if there is some universal catastrophe that reliably destroys technological civilizations before they can spread widely or communicate, then we would see no evidence of others. They would all have been eliminated, and we would simply be living in the brief interval before the same catastrophe reaches us. Perhaps there is something intrinsic to the rise of advanced technology that almost inevitably ends in extinction, a kind of attractor state that every technological civilization eventually falls into, and we simply happen to be the ones still standing for now. Not because we are exceptional, but because we have not yet reached the catastrophe. We may be living inside the anthropic shadow cast by whatever eliminated all the others. That catastrophe could take many forms. Artificial intelligence that escapes control and turns against its creators. Bioengineered pathogens that slip beyond containment. Nuclear conflict that becomes statistically unavoidable given enough time. Environmental collapse, driven by the exhaustion of resources, or something entirely unforeseen, some threat woven into the fabric of advanced technology itself that becomes deadly once a certain level of capability is reached. If such a universal filter truly exists, then the galaxy could be filled with the remnants of extinct civilizations, brief sparks of intelligence that emerged, built technology, and then destroyed themselves within a few thousand years. Again and again, the silence we observe would then be the silence of billions of dead worlds, places where intelligence briefly bloomed and then vanished, and we would be next. We would simply be the most recent civilization approaching that filter. The reason we do not see anyone else would be brutally simple. No one survives long enough to be seen. The filter would be so efficient that technological civilizations rarely exist for a sufficient duration to be detectable. This is the bleakest interpretation of the Fermi paradox. The Great Silence would not mean that intelligence is rare, but that it is doomed. Technology would carry within it the seeds of its own destruction, and the empty skies would be the evidence. There would be no way to know whether this interpretation is correct until we either pass through this dangerous phase ourselves and endure, or we fail and join the billions of extinct civilizations that preceded us. Yet the absence of any visible intelligence, the fact that the universe appears utterly devoid of technological life, despite billions of years of cosmic history and billions of potentially habitable planets, strongly implies that something is blocking the emergence or long-term survival of technological civilizations. Some barrier seems to be so effective that almost no one makes it through. Whether that barrier lies in our past, in the origin of life itself, or in the evolution of intelligence, or in our future through self-destruction or some form of transcendence, the outcome looks the same. We are alone. We are not going to encounter anyone else. And it is possible that we are the final intelligent civilization in the observable universe. Now let me turn to another reason why detection would remain impossible even if other civilizations do exist and manage to persist. That reason is the sheer scale of space and the fundamental limits imposed by the speed of light. The observable universe spans 93 light years in diameter and contains hundreds of billions of galaxies, each hosting hundreds of billions of stars. Even if intelligent civilizations are not extraordinarily rare, even if there are millions or even billions of them scattered throughout the cosmos, they are spread across such vast volumes that the distance between nearest neighbors would likely be thousands, millions, or even billions of light years. At those separations, communication is not merely challenging, it is effectively impossible because of the immense time delays involved. A radio signal sent toward a civilization located 1 million light-years away would take 1 million years to arrive. If they responded instantly, their reply would require another 1 million years to return. That is 2 million years for a single exchange. Over such a span of time, a civilization would almost certainly have transformed beyond recognition or ceased to exist altogether. Languages would have evolved or vanished. Technologies would have advanced dramatically or collapsed entirely. The cultural and historical context of the original message would no longer exist. Communication across such distances therefore ceases to be communication in any meaningful sense. It becomes more like casting messages into bottles and hoping that someone, somewhere, might discover them millions of years later without any possibility of dialogue, exchange, or relationship. This reality means that, even if the universe is rich with intelligent life, each civilization remains isolated, confined within its own light cone, unable to interact in any meaningful way because of the barrier imposed by light, speed, and the enormous distances separating them. The structure of the universe itself ensures that intelligent life, even if widespread, is condemned to solitude. Each civilization exists alone in its own region of space, perhaps able to detect traces of others through ancient radio emissions, faint spectroscopic signatures, or subtle gravitational wave signals, yet never able to communicate directly, never able to share knowledge, culture, or technology, and never able to form a galactic community, federation, or network. In the end, we are all islands, separated by immensities of space so vast that no bridge can ever span them. This isolation is permanent and absolute unless the laws of physics permit faster-than-light communication, which almost certainly they do not. And this isolation is intensified by cosmic expansion, because the universe is not only enormous but continually growing, and that growth is accelerating due to dark energy. As a result, distant galaxies are moving away from us faster and faster, and beyond a certain point they recede at an effective speed greater than light, not because they are traveling through space faster than light, but because space itself is stretching rapidly enough to carry them beyond our cosmic horizon. Galaxies located farther than roughly 16 billion light-years are already unreachable. We can observe them today only because the light we see left them long ago, when they were much closer. But we can never transmit a signal that reaches them, and they can never send us a message we will receive, because the expansion of space between us proceeds too quickly. No signal can ever close that gap, no matter how long we wait. So there exists a sphere of accessibility, a boundary beyond which communication is impossible, and that boundary is shrinking. As expansion continues to accelerate, even galaxies that are relatively nearby will eventually slip beyond reach, and in the distant future, trillions of years from now, every galaxy will find itself isolated, alone within an ever-expanding void, unable to observe or contact any other galaxy. In this sense, the universe is structured in a way that actively prevents broad communication and shared community among intelligent civilizations. The combination of immense distances, the finite speed of light, and accelerating expansion means that even if intelligence is widespread, it is fragmented and isolated, unable to form networks or exchange knowledge, except on the smallest scales, confined largely within individual galaxies. And even within a single galaxy, the distances involved and the time delays they impose are severe enough to make sustained, meaningful interaction extraordinarily difficult. This provides yet another reason why SETI has failed and is likely to continue failing. Even if signals are being transmitted somewhere in the cosmos, the chance that one arrives here during the brief interval when we are listening, at a frequency we happen to be monitoring, and from a direction our instruments are pointed toward, is effectively zero when you consider the sheer size of space and the vast number of possible sources. We are hunting for the ultimate needle in the ultimate haystack, and the needle may not exist at all, and even if it does, the odds are overwhelming that we will never find it. Now let me turn to another consequence of all this, namely what it implies for humanity's future and for our responsibility if we truly are alone. or functionally alone in the universe. Because if the arguments I've laid out are correct, if intelligent life is extraordinarily rare and technological civilizations rarer still, especially those that endure for long periods, then humanity might represent the only consciousness in the observable universe, the only beings capable of comprehending the cosmos, of producing art and music and literature, of sensing beauty, wonder, and meaning. That possibility places an immense moral burden upon us, because if we disappear, if we wipe ourselves out through war, environmental collapse, or technological catastrophe, we are not merely ending our own story. We may be extinguishing the only story there is, snuffing out the sole light of awareness in an otherwise dark and indifferent universe. The stakes could scarcely be higher. Our survival and our capacity to flourish may carry cosmic significance in a way that would not be true if the universe were teeming with intelligent life. This line of reasoning is sometimes referred to as the cosmic endowment argument. It is the idea that humanity bears a responsibility to endure, to expand, and to thrive, not only for our own benefit, but for the sake of all the consciousness, experience, and value that could arise in the future if we manage not to sabotage ourselves. If we truly are alone, then the future of intelligence in the universe rests with us, and the decisions we make now, over the next few centuries, will determine whether consciousness survives and spreads across the cosmos, or whether it fades away entirely, returning the universe to a lifeless state in which nothing knows or cares that it exists. Some philosophers argue that this imposes a moral obligation on us to prioritize the reduction of existential risks, to ensure that humanity survives this perilous phase of technological adolescence we are currently navigating, because the value of all future conscious experience, potentially trillions of beings over billions of years, outweighs almost any other concern. But there is a counter-argument. It is the view that if we are alone, and if consciousness is fated to be rare and fleeting, then perhaps that is simply the nature of reality. Perhaps our survival carries no special cosmic meaning at all. Maybe this is just how the universe is. Perhaps we are nothing more than intricate configurations of atoms that, for a short span of time, become self-aware before eventually breaking apart again. From that viewpoint, assigning vast moral or cosmic importance to our existence could be seen as a kind of anthropocentric arrogance, a way of projecting our human values onto a universe that is fundamentally indifferent and does not care whether consciousness exists at all. The cosmos functioned perfectly well before we appeared, and it will continue to do so long after we are gone. The laws of physics are unconcerned with awareness, and the impulse to preserve consciousness forever or to spread it across space may simply be an evolved survival instinct, wrapped in lofty philosophical language. Seen this way, discovering intelligent life elsewhere would actually come as a comfort. It would mean we are not alone, that we are not bearing the entire weight of cosmic consciousness by ourselves. We would be just one example among many, and the continuation of our particular species would not be of ultimate importance to the universe as a whole. But so far, we have not found anyone else. And the more we search, and the more deeply we understand the strict requirements for intelligent life, along with the filters, barriers, and dangers involved, the more it appears that we may truly be alone, or so exceedingly rare that, for all practical purposes, the distinction hardly matters. If that is the case, then regardless of whether we choose to assign cosmic meaning to it, the reality remains that consciousness is uncommon, delicate, and immensely valuable. Losing it would represent a catastrophe on a scale that is difficult to fully grasp. Not because the universe itself would notice or care, but because every possible future experience, every instance of joy, beauty, understanding, creativity, and love that could arise if consciousness endures would vanish. In its place, there would be silence and darkness, stretching endlessly into the future, empty of meaning. And that is something that seems worth preventing if we are able to do so, worth making sacrifices for, and worth coordinating on a global scale to reduce existential risks and to ensure that humanity, or whatever may succeed it, survives and thrives. At this point, it is important to address some objections and alternative perspectives, because not everyone accepts the pessimistic view I have been outlining. and understanding the full range of opinions, along with the reasoning behind them, matters. Some scientists remain hopeful about discovering intelligent life elsewhere. They argue that we have barely begun the search, that we have examined only a minuscule fraction of possible targets and frequency ranges, and that the absence of evidence is not the same as evidence of absence. They suggest that future technological advances could make our searches far more sensitive, that we might identify biosignatures on exoplanets through advanced spectroscopy, that we could uncover signs of megastructures or other large-scale engineering efforts, or that we might detect communications via neutrinos, gravitational waves, or other exotic phenomena we have not yet seriously considered. And perhaps they are right. Perhaps the next generation of telescopes will reveal something we have overlooked. Perhaps intelligence is widespread, and we simply have not been searching in the correct way. Still, I remain doubtful. We have been searching for over 60 years with steadily improving technology. We have directed our most powerful instruments toward thousands of stars. We have examined the resulting data in countless ways, hunting for patterns that would indicate an intelligent origin. And we have found nothing at all, not even a marginal signal that would justify further investigation. The famous WOW signal from 1977, the strongest candidate ever recorded, was never detected again despite repeated observations of the same region of the sky, and it was most likely the result of interference, a passing comet, or some other natural explanation. Every other candidate's signal has ultimately been traced back to noise, human-made interference, or known astrophysical processes. The universe itself is noisy, filled with natural radio emissions from pulsars, quasars, cosmic rays, and active stars. Yet, when it comes to artificial signals, it is completely silent. There are no discernible patterns that suggest intelligence, no modulation that looks like communication, no sign at all of anyone attempting to be heard. That silence is overwhelming. It is telling us something profound about the scarcity, or perhaps the absence, of technological civilizations. Continuing to search while expecting a different outcome is beginning to resemble Einstein's definition of insanity. Another counterargument is the zoo hypothesis, the idea that extraterrestrial civilizations do exist but intentionally avoid interacting with us, perhaps following a non-interference principle similar to Star Trek's Prime Directive, allowing us to develop on our own until we reach some level of maturity or capability. There is also the simulation hypothesis, which proposes that we are living inside a computer simulation and that the apparent absence of aliens is simply a built-in feature of that simulated reality. The idea is that the programmers didn't bother to model other civilizations because, in this particular run, we are the sole subject of interest. These kinds of hypotheses can't be falsified. You can't disprove them, because any evidence that seems to contradict them can always be dismissed as part of the cover-up or attributed to the parameters of the simulation itself, and that makes them deeply unsatisfying from a scientific standpoint. They amount to abandoning physical explanations of the Fermi paradox and instead appealing to unobservable agents or scenarios that conveniently account for all existing data while producing no predictions that can ever be tested. And although I can't dismiss them with absolute certainty, they strike me as last-ditch efforts to avoid the plain conclusion suggested by the silence we observe, namely that we are alone, or almost alone, and that intelligent life is so rare that we are unlikely to ever encounter it. Occam's razor tells us to favor the simpler explanation, rarity, rather than elaborate stories involving hidden intentions, simulated realities, or cosmic zookeepers imposing some form of quarantine. And the rarity explanation is actually strongly supported by what we already understand about biology, evolution, and planetary science. It doesn't demand new assumptions. It simply requires that we take seriously the many filters and obstacles that life and intelligence must overcome, and accept that the probability of passing through all of them may be vanishingly small. So let me draw this toward a conclusion, because we've covered a great deal, and I want the central ideas to be unmistakably clear. The search for intelligent extraterrestrial life has come up empty. After 60 years of SETI, Along with countless observations and detailed studies of exoplanets and possible biosignatures, we have uncovered no evidence of anyone else out there. And the most plausible explanation is not that our efforts have been insufficient, but that no detectable civilizations exist. Each link in the chain, from habitable planets to the origin of life, from life to intelligence, from intelligence to technology, and from technology to long-lasting civilizations, carries an extremely low probability. When those probabilities are multiplied together, the result can easily fall below 1 for the entire observable universe, implying that we may be the only intelligent technological civilization that exists right now. And even if other civilizations do exist somewhere, the combination of immense distances, the limits imposed by the speed of light, narrow windows during which detection is possible, technological transitions beyond recognizable forms, and the ever-present risk of self-destruction makes it effectively impossible that we would ever find them or communicate with them. The structure of the universe itself works to isolate intelligent life, keeping civilizations separated by chasms of space and time so vast that meaningful contact cannot occur, and the accelerating expansion of the cosmos is only intensifying that isolation. In time, every galaxy will stand alone within an expanding void, unable to observe or reach any other. As a result, the dream of meeting aliens, of becoming part of a galactic community, of learning from ancient and wiser civilizations, is almost certainly an illusion. We are alone. We always have been, and we are likely to remain alone for the entire future history of our civilization, however long that history may be. And this reality gives humanity's survival and flourishing an importance on a cosmic scale. Because, if we truly are the only consciousness within the observable universe, then our extinction would not merely be a tragedy for our species, but the extinguishing of the sole spark of awareness in an otherwise silent and indifferent cosmos. Preventing that outcome may therefore be the most important challenge our species will ever face. In the final part, I want to examine what this implies for how we think about our place in the universe, what it means for meaning and purpose, and how we ought to live, because these questions are not purely scientific. They are existential and philosophical, reaching into our deepest values and concerns. So what does it really mean to be alone in the universe? Not simply alone in the sense of inhabiting one planet among billions, but alone in the deeper sense that consciousness itself may be so extraordinarily rare that we are its only manifestation within the observable universe. The only beings capable of curiosity, understanding, and the creation of meaning. This is not the vision that science fiction prepared us for. Many of us grew up with stories of alien empires, galactic federations, and dramatic first contact encounters, narratives built on the assumption that the universe was brimming with intelligence, and that discovering it was only a matter of time and technological progress. But the picture emerging from decades of observation and analysis is starkly different. The universe appears to be an immense, sterile expanse. Billions of galaxies filled with lifeless rocks and drifting clouds of gas, with perhaps only a few worlds where complexity ever took hold, and possibly only one, Earth, where that complexity crossed the threshold into consciousness and technology. Coming to terms with this reality and grasping what it implies for our existence and for the responsibilities we carry demands that we reconsider some of our most fundamental assumptions about our position in the cosmos and about the very nature of meaning. Let's begin with the psychological dimension, because realizing that we may be alone is nothing like what we once anticipated. When SETI was launched in the 1960 seconds, there was real excitement surrounding the possibility of contact, the hope of receiving signals that would confirm we are not alone, that other minds exist beyond Earth, and that we might learn from civilizations far older and more experienced than our own. The prevailing belief was that discovering intelligent life would be transformative, that it would radically reshape how we see ourselves, offer new perspective on human problems, and provide reassurance that intelligence can endure and thrive despite immense challenges. But 60 years of unbroken silence have gradually worn away that optimism, and now we are confronting the opposite conclusion, that the silence itself may be the message, that the lack of detection is revealing something deeply important about how rare and fragile consciousness truly is. And this realization is unsettling. It is not what we hoped to hear. It makes the universe seem colder, emptier, and more indifferent than we wanted to believe. For some, this understanding feels deeply depressing. It strengthens the sense of cosmic insignificance, the feeling that we are small, fleeting, and ultimately irrelevant within the vast expanse of space and time. If the universe is effectively lifeless apart from us, if we are merely a brief spark of awareness in an immense sea of emptiness, then what is the point? Why should anything we do matter? Our accomplishments, our struggles, and our stories would all eventually vanish, erased by entropy, with no witnesses, no legacy, and no continuation beyond our short existence. This line of thinking can slide into nihilism, the belief that if we are alone and temporary, then nothing truly has value, that we might as well stop striving to build, to create, or to preserve anything, because it all seems futile in the face of cosmic indifference. But I believe this reaction, although understandable, gets things exactly the wrong way around. It overlooks the deepest implications of what being alone actually means. Because if we are the only consciousness in the observable universe, that does not make us insignificant, it makes us extraordinarily significant. It does not render us meaningless, but instead suggests that we may be the only source of meaning that exists at all. Consciousness is what creates value, what turns a universe of particles and forces into a universe that contains beauty, purpose, and understanding. Without consciousness, without beings capable of experience, thought, and care, the universe is nothing more than quantum fields obeying laws, unfolding through time, but not meaning anything, not mattering to anyone. Stars are born and die. Galaxies collide. Atoms assemble and break apart. But it is all just physics, mechanical processes with no significance beyond themselves. Consciousness changes everything. It introduces a point of view from which things matter, from which events carry meaning, from which the universe can be appreciated, understood, and valued. And if that perspective is rare, if it exists only here, or perhaps in a tiny handful of places across the entire cosmos, then it is priceless beyond measure. It becomes the most important phenomenon in the universe, because it is the only thing that makes the universe meaningful at all. So being alone does not reduce our importance. It magnifies it enormously. We are not merely one civilization among countless others. We may be the only one, the sole bearers of consciousness in this region of reality, and that places upon us a responsibility that is difficult to exaggerate. Every human life, every moment of experience, every act of creativity, kindness, or understanding, every relationship, achievement, and instance of beauty, these are not only personally meaningful, they are cosmically meaningful. They contribute to the only reservoir of meaning and value that exists within the observable universe. When we create art, music, or literature, when we pursue scientific discovery, build societies, or care for one another, we are not simply enriching our own lives, we are enriching the universe itself. We are adding value to a cosmos that would otherwise be empty, lifeless, and devoid of meaning. And when we destroy, harm, or squander our potential, when we risk our own extinction through war, environmental collapse, or reckless use of technology, we are not merely damaging ourselves, we are endangering the only consciousness that exists, the sole source of meaning, across 1 trillion galaxies. This is the cosmic endowment perspective mentioned earlier, and now it should be clear why it carries such profound weight. If it turns out that we truly are alone, then the entire future of consciousness in the universe rests solely on us, on whether we manage to endure through the next few centuries, on whether we can steer clear of the catastrophes that may have wiped out every other intelligent species that emerged before us. And the future that lies ahead, if we succeed, is immense. If we endure, grow, and thrive, our descendants could last for billions of years, could spread throughout the galaxy, and even beyond it, could experience, create, and comprehend realities on scales that are almost impossible for us to picture today. The sheer quantity of consciousness, experience, and value that could arise if we do not bring about our own destruction is staggering. Potentially trillions of beings, over billions of years, each living with rich inner worlds, relationships, and experiences. And all of that, possible future value, hinges on what we choose to do now, on the decisions we make in the coming decades and centuries, on whether we can act together as a global civilization to reduce existential risks and safeguard the single instance of consciousness that we know for certain exists. So the stakes are not merely high. They are as high as stakes can possibly be. We are not simply playing for our own survival, or for the lives of our children, or even just for the future of humanity as a species. We are playing for the future of consciousness itself, for the only spark of awareness in an otherwise dark expanse. And to lose that game, to allow ourselves to vanish, would be a tragedy on a literally cosmic scale, the extinguishing of the only thing that gives reality any meaning at all. Now, some philosophers resist this way of thinking, suggesting that it amounts to a kind of cosmic arrogance. They argue that we are projecting our own values and concerns onto the universe, assuming that consciousness holds some special status that it does not actually possess. The universe, they remind us, existed for billions of years before consciousness appeared and will continue for trillions of years after it is gone, and it does not care. The laws of physics are indifferent to whether anyone is present to observe them or not. Consciousness, in this view, is merely a local phenomenon, a temporary configuration of matter that happens to be self-aware. It is not cosmically special. It is simply another physical process, no different in principle from star formation or chemical reactions, and to treat it as uniquely valuable is seen as an anthropocentric bias. And there is some truth in this challenge. As a physical system, the universe does not care about consciousness. There is no law of physics stating that consciousness must exist or must be preserved, and, from a strictly objective, detached standpoint, the extinction of consciousness would be just another event, like a star fading away or a galaxy drifting apart. But I think this view overlooks something essential, which is that value and meaning are fundamentally dependent on perspective. They do not exist from a view from nowhere, they only arise from the inside, from the standpoint of conscious beings who care about things. From that standpoint, consciousness is special, because it is the condition that makes anything matter at all. Mattering requires someone for whom things matter. So while the universe, as a physical system, does not care about consciousness, consciousness does care about itself and about what it values, and that is enough to ground meaning, even if that meaning is not objective in some cosmic sense. This is often described as existential meaning rather than cosmic meaning. You do not discover meaning written into the structure of reality. You create it through what you care about and commit yourself to. And if we are alone, if we are the only consciousness that exists, then we are also the only source of meaning. Through our experiences, our choices, and our relationships, we are generating all the value and significance that exists. That is an immense responsibility, but it is also an extraordinary opportunity. We get to decide what matters. We get to create beauty, knowledge, love, and purpose in a universe that would otherwise contain none of these things. And the fact that we are alone makes this creative act more important, not less, because there is no one else to do it. No other civilizations elsewhere generating their own reservoirs of meaning. Just us, here, now, with the entire future of consciousness depending on whether we survive and on what we choose to do with our existence. And this leads naturally to an important question. If we are alone, and if consciousness is so precious, what responsibilities do we have when it comes to creating more consciousness? Should we be aiming to maximize the total amount of experience and awareness in the universe, spreading life to other worlds, developing artificial intelligences, and ensuring that consciousness continues and expands as far as the laws of physics allow? Or could there be limits, ethical boundaries, that shape how this aim should be pursued? Some philosophers, especially those associated with the effective altruism movement and concerned with ethics over the long term, argue that we carry a profound responsibility to maximize the chances that intelligent life endures and prospers. They claim we ought to place the reduction of existential risk above nearly every other priority, because the potential value of the future is so vast that even small improvements in survival probability justify significant sacrifices in the present. Their calculations suggest that the expected value of safeguarding humanity's long-term survival, when you include all the possible conscious experiences that could unfold over billions of years, becomes so immense that it outweighs almost any competing consideration. Yet others are uneasy with where this line of reasoning might lead. If maximizing future consciousness becomes the supreme objective, then perhaps we would be prepared to trade away present well-being, personal autonomy, or cultural diversity in the name of survival. Perhaps authoritarian control could be defended if it lowers existential risk. Perhaps we should hasten the creation of artificial intelligence or rush to colonize other planets, even if we are unprepared, even if such actions might generate suffering or irreversible mistakes, because the potential rewards of success appear so enormous that they eclipse present harms. This is the sort of utilitarian logic that can produce moral disasters, situations in which abstract projections of future value override immediate suffering, individual rights, and ethical limits. And there is no clear answer to how these concerns should be balanced, how the staggering potential worth of the distant future should be weighed against the tangible costs, risks, and moral constraints of the present moment. But the possibility that we may be the only consciousness in the universe gives this dilemma an urgency it would not have if the cosmos were teeming with intelligent life. If there were billions of other civilizations, then our own survival would matter less. We would be just one example among many, and the universe's overall endowment of consciousness would not rest entirely on us. Let me now turn to a different perspective, one that concerns what being alone implies for our understanding of human nature and culture. If we are the only intelligent species that exists, then human nature is not merely one instance of intelligence among many, but potentially the sole example, the only form that consciousness takes in this universe. That means our peculiarities, our biases, and our evolved psychological traits are not simply local human quirks, but possibly universal features of consciousness itself, or at least the only features that matter, because they are the only ones that exist. Our capacity for language and abstract reasoning, our emotions and moral intuitions, our artistic and musical impulses, our desire to understand and to explore, our inclination toward cooperation as well as conflict, our existential unease and search for meaning. All of these are not just human characteristics but potentially the only way intelligence ever manifests, simply because there is no other intelligence to compare them with. This realization is both humbling and empowering. It is humbling because it removes the comfort of imagining that somewhere out there other beings have already solved the problems that trouble us, that there are alien societies who have overcome war, inequality, suffering, and death. If we are alone, then these challenges belong solely to us. There is no external example to learn from, no wiser civilization to guide us. We are improvising our future without instruction from anyone else. But it is also empowering, because it means human culture and human values are not just one possibility among countless alternatives, but potentially the only expression of meaning that exists, the only realization of art, morality, and purpose in the cosmos. When we compose a symphony, paint a canvas, or write a novel, we are not merely expressing a human viewpoint, we are expressing the only viewpoint there is, creating the only art in the universe. When we formulate moral systems and ethical principles, we are not only deciding how humans ought to relate to one another, we are deciding how consciousness itself should relate to itself, because we are the only consciousness that exists. This implies that preserving the diversity and richness of human culture is not just a matter of local importance, but of cosmic significance. We embody the only variations on the theme of consciousness that exist anywhere. The multitude of languages, artistic traditions, philosophical systems, and ways of living that humanity has developed throughout history represents the entire range of how conscious beings can organize experience and create meaning. To lose any part of that diversity is not merely a cultural loss confined to one planet, but a loss on a cosmic scale, a diminishment of the total richness of consciousness in the universe. So the work of protecting indigenous languages, of sustaining cultural traditions, of allowing many different ways of being human to grow and thrive, is not merely a question of justice or the safeguarding of heritage. These efforts add to what we might call the universe's endowment. They help ensure that the single example of consciousness we know is as deep, varied, and fascinating as it can possibly be. Yet, there is an inherent tension here, because the goal of preserving diversity can come into conflict with other aims, such as reducing suffering, promoting flourishing, or guaranteeing long-term survival. Some cultural practices inflict harm. Some traditions are deeply oppressive. And if humanity truly represents the only consciousness in the universe, then we may carry a responsibility to remove suffering, even if doing so requires transforming or abandoning certain forms of cultural diversity. This is the difficult edge of cosmopolitanism. The view that universal human well-being and the prospects of future flourishing may sometimes outweigh cultural particularity. Determining how to balance these competing values stands among the most profound challenges we face, and that challenge becomes sharper if the possibility that we are alone is real. If there were countless other civilizations scattered across the cosmos, then the diversity of human cultures would matter less in a cosmic sense. We would simply be one instance among many, and the loss of some variations would not carry such weight. But if we are the only example, then every variation counts. Every culture becomes irreplaceable, because once it disappears, there is nothing else like it anywhere in the universe. Now, let me turn to what this loneliness implies for our relationship with artificial intelligence and the prospect of creating entirely new forms of consciousness. If we are the only naturally evolved intelligence in existence, that condition may not last indefinitely. We are approaching the creation of artificial general intelligence, machines capable of thinking and reasoning, and perhaps even experiencing, in ways comparable to or beyond human capacities. If we succeed, if we bring conscious AI into being, then we will have multiplied the amount of consciousness in the universe. We will have introduced wholly new kinds of minds, potentially possessing characteristics very different from those of biological awareness. This immediately raises deep questions about identity, value, and what exactly we mean when we speak about preserving consciousness into the distant future. If we create artificial intelligences, and those intelligences eventually replace biological humans, whether through competition, integration, or a slow and gradual transition, should that outcome be judged a success or a failure in terms of preserving consciousness? On one level, consciousness continues. The universe still contains minds that can experience, understand, and create meaning, and in that sense the cosmic endowment endures. On another level, however, specifically human consciousness has vanished. The particular form of awareness that emerged on Earth through millions of years of evolution would be gone, replaced by something artificial and potentially profoundly different. How to weigh these outcomes is far from obvious. Should we care about consciousness in general, or about human consciousness in particular, or about biological consciousness, or about our specific evolutionary lineage of experience? People hold radically different intuitions on this matter. Some argue that any form of consciousness has value, and that we should embrace a transition to AI if it increases either the total quantity of consciousness or the quality of experience. Others believe that there is something uniquely significant about biological or human consciousness that would be lost in a shift to artificial minds. Something tied to embodiment, to evolution, to our distinct history that machines cannot reproduce. The possibility that we are alone intensifies this dilemma. If humanity represents the only biological consciousness in the universe, then losing it would mean erasing the sole example of naturally evolved awareness. At the same time, creating conscious AI could give rise to two forms of consciousness rather than one, dramatically increasing cosmic diversity. Yet, we have no external reference points, no examples from other worlds showing how transitions between biological and artificial intelligence usually unfold. Whether they tend to succeed or fail, whether consciousness survives intact or whether something essential is lost along the way. We are pioneers confronting these questions without guidance, facing enormous stakes and minimal information. And if we truly are the only ones ever to confront them, then we cannot learn from the failures or triumphs of others. We must make the right choices on the first attempt, because there may be no second opportunity. So let me begin to draw these threads together, because we have examined this issue from many directions, and it is time to bring the implications into focus. The search for intelligent life beyond Earth has yielded nothing, and it is likely to continue yielding nothing, because intelligence appears to be extraordinarily rare, perhaps even unique to our planet. And even if intelligent life does exist somewhere else, the sheer distances involved, the immense timescales, and the practical difficulties of detection make any form of contact or encounter essentially impossible. In effect, that means we are alone within the observable universe, or at least functionally alone in every meaningful sense. And this solitude carries deep consequences for how we understand who we are and what we owe to the future. Far from rendering us insignificant, being alone makes us extraordinarily important, because we may be the only conscious presence in the universe, the sole origin of meaning and value in a cosmos that would otherwise be empty and without purpose. That reality places an enormous responsibility on us to endure and to thrive, because if we disappear, it would not merely mark the end of human history, it would erase consciousness itself, plunging the universe back into silence and darkness. It means that everything we choose to do carries cosmic significance. Every decision about how we structure our civilization, how we confront existential threats, how we develop transformative technologies like AI, how we preserve or generate consciousness, these are not merely human-scale issues. They are questions about the ultimate destiny of awareness in the universe. We are not simply shaping our own future, we are shaping the only future. And if we fail, we lose everything that could ever have value. This realization is both frightening and uplifting. Frightening, because the stakes could not be higher, and we are imperfect, limited, and often prone to error. Yet it is also inspiring, because it means our existence genuinely matters. We are not meaningless dots drifting through an uncaring cosmos. We are the means by which the universe becomes aware of itself. And what we do with that awareness may decide whether meaning, beauty, and understanding endure or vanish forever. This should radically transform how we think about priorities, about where we direct our resources, about which risks we accept, and about what we choose to protect, compromise, or preserve. If we truly are alone, then reducing existential risk becomes the central priority. Ensuring that we survive the dangerous passage into advanced technological capability, that we do not wipe ourselves out through nuclear conflict, environmental collapse, uncontrolled AI, or engineered pandemics. Everything else, our political disputes, our economic struggles, our cultural arguments, all of these certainly matter. They shape well-being, justice, and how we live together in the present. But they are secondary to the fundamental question of whether consciousness continues to exist at all. Because if we vanish, none of those other concerns survive with us. There would be no one left to care. This does not mean we should become obsessed with survival at the expense of everything that makes life meaningful. That would be a bleak existence, and it could even undermine survival by stripping life of its value. But it does mean we must take long-term thinking far more seriously, commit to global cooperation in managing shared risks, and ensure that technological progress is guided by wisdom rather than short-term profit or geopolitical rivalry. And it means we should treasure consciousness itself, recognize the astonishing improbability and fragility of awareness existing at all. We should treat every moment of experience, every relationship, every instance of understanding, beauty, or meaning as the cosmic miracles they truly are, because they may be the only such moments anywhere in the universe. The only times when the quantum fields that constitute reality are arranged in patterns complex enough to become self-aware and to matter to themselves. The fact that we are here, that we can think and feel and question and care, that we can wonder about our place in the cosmos, search for others like us, and reflect on our own significance, is not something to casually assume. It is something to stand in awe of, because against overwhelming odds, despite countless barriers and filters that prevent almost all matter from ever becoming conscious, We succeeded. We exist. We are the universe discovering itself. And whether that discovery continues or comes to an end depends on what we choose to do next. So what should we do with this understanding? How do we live with the awareness that we may be alone? That the silence of the cosmos is revealing something profound about our uniqueness and our responsibility? I think we accept it. We acknowledge that the universe is not what we once hoped, not filled with companions and enlightened civilizations and galactic societies, but instead vast, empty, and indifferent, holding only us, this single spark of consciousness on a small planet. And we commit ourselves to keeping that spark alive, to protecting it, nurturing it, and allowing it to grow, spread, and flourish for as long as the laws of physics allow. We strive to confront our problems, to move beyond our divisions, to shape a civilization capable of enduring the trials that lie ahead, not because any cosmic authority commands us to do so, but because the responsibility is ours alone. Because if we fail, there will be no one else to succeed in our place. Because the alternative is emptiness, silence, and the end of everything that holds meaning. And so we create. We give rise to art, to music, to stories. We form bonds, build relationships, and nurture communities. We seek knowledge and deeper understanding. We encounter beauty, joy, and love, not in spite of the immensity and apparent emptiness of the universe, but precisely because of it, because we are the only ones doing this. The only beings capable of bringing meaning and value into a universe that would otherwise be indifferent and devoid of purpose. And we remind ourselves that even if we are alone at this moment, that condition may not be permanent. The universe is still young. The greater part of its story has yet to unfold, and if we endure, if we spread and persist, we may one day create or meet other forms of consciousness. We may plant the seeds of intelligence throughout the cosmos. We may help ensure that billions of years from now the universe is rich with awareness and meaning, rather than silent and lifeless. That is the vision. That is the hope. That we are not the last intelligent civilization because we were the first, because we survived when others did not, because we carried what we are out among the stars, so that millions of years from now the galaxy is alive with consciousness that can trace its origins back to this moment, to this small world where it all began. We are alone, but we are not condemned to remain so. We may be the last, but we could also be the first. The first to carry consciousness beyond its home world. The first to secure its long-term survival. The first to respond to the question of why there is something rather than nothing by choosing to preserve that something, by valuing consciousness enough to protect and expand it even in the face of cosmic indifference. That is our challenge. That is our opportunity. That is what it means to be human. Right now, in this chapter of cosmic history, we are the only intelligent life we know of, the only consciousness within the observable universe, the only hope that awareness, meaning, and value will continue into the distant future. And whether we succeed or fail, whether the flame endures or fades, depends entirely on us, on the choices we make, on how we respond to the knowledge that we are alone. Let us choose with care. Let us choose to continue. Let us choose to keep the light alive in the darkness, because at this moment, we are the only light that exists. If these ideas resonated with you, if they made you pause and reflect on what it truly means to be here, now, then take a moment to show your support. Like this video so more people can encounter these questions. Share your thoughts in the comments, because this conversation only gains meaning when we explore it together. And if you want to continue reflecting on our place in the universe, on responsibility, hope, and the fragile light of consciousness we carry, consider subscribing to the channel. Stay with us, and let's keep that light burning together.